I'm so happy that we have Etienne here to give us a wonderful presentation. To introduce Etienne, she's the founder of Polyglots and is a research engineer working on projects for the Institute for Applied Linguistics of URAC. She has a 10-year career as a software developer, ranging from web development to cloud infrastructure, and recently specialized in computational linguistics. So in this talk, Etienne will cover details about what exactly computational linguistics is, what you can do with it, how to break this applied in language learning, and where you can find resources to learn more. So I'm so excited for this, Etienne. I'll leave it up to you. Any questions, please put them into the chat and I'll ask you later. Thank you.
Hello all. Well, thank you so much for organizing the conference, people from ChatterConf. And I'm really glad the solutions are, everything seems to be working now. Let me know if we stumble into some other problems. But yeah, I'm really excited to talk to you today about computational linguistics. So a little bit about myself. Thank you for the introduction, but I just want to say some additional stuff. So yeah, I come from a software engineering background. So I got into computational linguistics on my master's degree, which I just finished recently. And yes, I love learning languages. I love learning about learning languages, education. I care a lot about these things. I am currently developing polyglots, and I also work as a research engineer for URAC. And so let's get started. So what I want to cover today is what is computational linguistics, what is a language model, what you can do with it, and how it can be applied in language learning applications. And then if I have the time, I'm going to go a little bit about the career and resources for you to keep learning after this talk, right? So let's start. So what is computational linguistics? As the name might give you a hint, it is an intersection. So it is a research field at the intersection between computer science and linguistics. But not just that, there are other fields that are very useful in researching this, especially neuropsychology, philosophy, because when you start dealing with language, you also start dealing with matters of knowledge, right? So it can get very complicated. But typically, computational linguistics involves getting textual or audio data, so crowdsourcing what is the data that we're working with for our analysis, then annotating and augmenting this data so we have more information to work with, then analyzing all of this data and working with big chunks of storage, big chunks of stuff, and getting it working in a useful pipeline. And then there is, of course, digesting and creating models and predicting useful things with this language, and then use that to create applications, right? So those applications can be from simple things like counting words, so like a word counter, or for example, more fancy things like getting exactly the answer that you're looking for from a search engine, or even having like a full dialogue with a mobile assistant, right? So there is a range of things where you can use computational linguistics. My slide got stuck. Okay, so before we continue, I just really want to explain a little bit about the difference between computational linguistics and NLP, because this is something that you are going to see around in the wild as soon as you start diving into the subject. And I just want to avoid confusion, like what is the difference? And the reality is that there's basically no difference, right? Personally, sometimes I observe that computational linguistics can be a little bit more about using the natural language processing, or NLP, tools for understanding more about language, where in NLP, it could be more about using the linguistic knowledge to create more tools. But both of these things need each other and they are used interchangeably. So if you see those two things in the wild, don't worry about it. But the term computational linguistics itself and the emergence of it as a research field started showing up in the 60s or 50s. And although we can trace back all of the history of computing things for a language to when the first Arab mathematicians started doing frequency analysis of text to decrypt messages, since then, like the computation itself has been very attached to the notion of language. You can think of computers as being like very numerical focus, like doing ballistic calculations for World War II when it all started. But decryption was also a big part of it, and that's when, for example, the Turing test was proposed, when a robot can fool another human that it is a human. So it was also a matter of artificial intelligence and robots in general, and not just applications like machine translation. But the first experiments with machine translation were in the 60s, and it was like this big thing at the time, right? They were not statistical, they were very synthetic rule-based, but with those rules, they were able to translate like 60 Russian sentences, and it was huge, right? They were very impressed, everyone was very optimistic. So the vibe at the time was like, oh, machine translation is going to be a solved problem in 3 to 5 years. And 10 years later, they were still struggling with it. Today, we know that machine translation is not exactly a solved problem yet. And the reason is that language is hard, right? So how can a computer understand language, right? When I say something like, we saw the Eiffel Tower flying to Paris, and I ask, who's flying? A computer only sees a sequence of characters, a sequence of words. So a computer can't answer this question very easily. As a human, I know that very obviously towers can't fly. So I can say with certainty, oh no, we were flying. That's the answer to this question. So it gets very tricky. You can't just do everything with just rules. And the problem is that sometimes not even humans know the answer to these questions. So if I say, Monica got the bath ready for her daughter wearing a pink skirt, and I ask, who is wearing the pink skirt? Humans don't have an agreement in this, right? And some people will say the daughter, some people will say Monica, and so it starts getting trickier and trickier for computers. So how do they solve that? And one way is creating a language model. Language model is a statistical tool, right? It's a statistical model that simulates language. And the goal is to answer this one question. All it has to do is to answer this one question. How likely is a sequence of words? Like, what is the probability that this sequence of words exists in the real language? So a good model would assign a real text in that language a very high probability. And with those probabilities, then it's able to predict the continuation of these sequences. And this is very useful for applications like autocomplete, for example, and also the dialogues and the chatbots where you have to continuate, one saying with something else, right? Like a whole sentence sequence as well. So they used to be built by measuring how you transition from one word to another, right? But that has its limitations, especially because you only have a very short memory. You're only keeping information about one word. If I know how do we go from one word to another? And there are more modern ways of doing that. So there are ways that are even more modern than this. And I'm just going to explain this very superficially. But another way we can create a language model is with word vectors. So it starts with spreading all of the words in a language randomly in a space, right? I'm just distributing them anywhere. And here I'm using 2 dimensions, so just putting it like in a normal chart. A real model, a fancy model, would use 300s, but it works exactly the same way. So what do we do? So we have these words randomly, right? And we start navigating through our data sets, and we start kicking these words around as they appear closer to each other as we go through our texts, right? And we do this many, many times. So we keep doing that with every chunk of data that we analyze. And the beautiful thing is that in the end, the words will naturally gravitate towards each other, forming these clusters, right? And they are clusters of similarity. You can see on this information that there is something about how these words are closer to each other in this chart, where it means something. And then we can use this distance between these words in these charts to make mathematical calculations about what they mean. And so we can do things like king minus man plus woman equals, and then you're gonna find the value for the word queen. And the first time I learned about this, I was like mind blown. Like, this is amazing. This is beautiful. But it's important to have in mind that when I say similarity here, I don't mean synonyms, right? You know, cat and dog are obviously very different words. They have different meanings. And so is good and bad, right? So good and bad would also appear very close to each other in this chart, and they mean very different things, but they are used in the same context, right? So I can say this movie is really good, or this movie is really bad. So in the real world, it looks like this, right? After you go through all of the Wikipedia and you start having like this huge infestations, this huge clouds of words grouped together. If you want to play around with this and see the words and how they connect to each other, you can go to dissected.it. You can type in the words and see them moving around. And if you want to learn more details about how this works, there is this website, Towards Data Science, and it has like very detailed tutorials about how to build this from scratch. Right. So as I was saying, these models, they are still imperfect, right? My slides are stuck again. Bear with me. Oh no, I can't pass my slides. Ah! No, that was absolutely not what I wanted to happen. Okay, bear with me. Okay, we're back. Sorry about that. So yeah, as I was saying, these models, they have like some notion of similarity, but all they do is saying what is a likely word, right? They are working in terms of probability. It doesn't mean that they are correct. They don't have intelligence. They can't, they don't know things. They're just stringing words together, creating words together in a way that sounds like it makes sense, in a way that works in the language. It doesn't mean that they know something. So GPT-3 is a very modern model for simulating language. And it's used for creating very fancy chatbots, which look like they can speak, but information-wise, it's very complicated. And I want to call attention to that because we all know that language can be weaponized to cause harm, and technology can scale that, right? So if you're going to remember one thing from this talk, please remember this. Just because you can use artificial intelligence, just because you can't use fancy technology for something, doesn't mean you should. It's not necessarily prepared for it. If you want more information about this, I suggest following Emily Bender on Twitter. She knows a lot more about this than I do. But yes, it's very, very, very dangerous. Watch out for these kinds of models. They are not ready for some kinds of use. Right? So what can they be used for? And how can they be used for language learning more specifically? So I want to show you how I use it in polyglots, but I'm gonna give you a short overview first. So there is a research field called computer-assisted language learning. I'm gonna short it as CALL because that is very long to pronounce. And there are traditional ways where you can use NLP, natural language processing in CALL, right? One of them is concordancing, which is finding all of the instances of a word in a text. So you can see how the same word is used in different contexts, and that is very useful as a learner. There's the opposite of that, which is the alignment of texts. Like, for example, Lingui, right? Where you have the same context, but the words are different. They're words in a different language. Then you have lemmatizing, which is reducing a word to its shortest form. So you can look for it in a dictionary, for example. But the golden ideal, the great objective of computer-assisted language learning is being able to parse learner input and provide feedback, and provide useful feedback. And there is lots of research going on right now about using chatbots for that, but it's very, very tricky. We're simply not there yet. So most of the times, these applications, they will be perceived as something very interesting, as a novelty, but not particularly useful. And the reason is that this is a very big task. It's a very big thing to ask from a computer, because for you to have a bot that does that, the first step is passing the Turing test, which is something that no system has ever done yet, which is the system I mentioned before, where you have such an artificial system that can fool another human that it is a human. And we aren't there yet. And this is just step one of reaching true integrative, intelligent computer-assisted language learning, right? So first, the bot has to talk so naturally to you that it can just, be there. Then it has to understand learner language, which is not necessarily the most likely type of language, right? It's going to have mistakes, it's going to have wrong combination of words. So it has to understand that, and then it has to diagnose those mistakes, right? And I don't mean just spotting them. I don't mean just realizing that there is something wrong by saying, oh, this is not likely. I mean diagnosing the cause of why you made a mistake and giving you exactly the explanation that's going to help you fix it. So, this is something that is going to take us some time to reach, in my opinion. And the second issue in modern computer applications and language learning is the research itself is overwhelmingly focused on English, right? This is a problem in research where it just needs more diversity of languages, and it's growing, but it's really not comparable right now for a range of reasons. It could be like access to data, it could be just people don't have the resources to do this research on specific languages. And that means that even if we get closer to this stage for English, it doesn't mean that it will be transferable to the other languages. So even when we get close, we will still be very far. And the other problem is that the intersection between second language acquisition research, so language learning research, and the application of this research for computerized systems is also small. And in my observance, the reason for that is that there are fundamental differences in the motivation of these fields, right? Because language learning research traditionally has been made for the scenario of a formal classroom where there is a teacher in the middle who is the target of this research, right? So this teacher is going to use the research to improve their methodology, right? So there's this person in the middle. And computer applications, they are created for a different scenario completely, right? The goal is usually to reach where a teacher will not reach. It's scaling beyond the current limitations, right? So either because the person doesn't have enough time or because they can't pay for a teacher, it's too expensive, it demands many hours for a teacher to bring someone to a basic level of a language. Or, it's just impossible in some way. And that is the goal of computer-assisted language learning many times. So it's difficult as an application developer to find research that supports me in doing that, because the research that currently exists is made for a different situation. There are newer research methods. There is lots of recent initiatives to transform this research into a more learner-centered field. And there are theories that can be applicable to this, like complex dynamic systems theory, but those are all very recent, right? Traditionally, the field was focused on classrooms. So how do computer applications circumvent that? Like both the lack of technology to do what it wants and sometimes the lack of theory to support this new type of medium, right? And the question is often going back to humans, right? So in Duolingo, for example, it can tell you that you made a mistake, but it can't tell you why. So what did you do? Then you can click on the forum button, and then you can ask questions, you can see the other comments. So the solution is often this human fallback. And at some degree, this is what I do in polyglots too. So I also rely on humans to create this feedback. And I also try to do that in more ways than just the feedback. I try to encourage these human interactions in more ways than just where NLP for a classroom scenario fails. Because, for example, I could transport media without necessarily creating content specially for that media. For example, I can, those old cassette tapes, audio courses, right? You can burn that into a CD. You can upload that to a website, and it's available in a new media. But fundamentally, nothing has changed about the methodology of that course, right? Or you can try to benefit for all of the possibilities that this new media provides, and all of these connections and the whole of the internet, and so on and so forth. So before I continue about how I do this, just to give you a quick overview of what polyglots is, because it's very new and it was part of my master's project, so you might not have heard of it, and it's quite small. So I started developing polyglots for my master's, and the goal is that you play with other humans, so you develop your communication in a collaborative environment, but in a very easy way. So you have images, and you guess the images and write whatever you want. And that means that it's good for people in that like A2, B1 level, where a full language exchange app is either too difficult or too stressful. So the iOS app is still in private tests, so people can't download it yet. But just for the people of ChatterConf, if you want to have a look, if you want to give me feedback, if you go to polyglots.app/ChatterConf, I put a link specially for you, so you can just download it right now, and for both iOS and Android as well. Right, so going back to how I use NLP in polyglots in a way that's adapted to this new media, right? And I do two things. The first thing is evaluating what people write. And the second thing is in a feature called word steps, right? So evaluating what people write is very interesting because it's something I can do with the data I get from the players, right? Because since people can write whatever, they can write anything, they can write simple expressions, they can make words trivias, they can make intercultural jokes, they can go completely nuts, right? So I can see exactly how they are using their internal language. And then I can analyze that in very interesting ways. So this was basically my master's research. So remember what I said about language models, that it gives you a score, it gives you the probability of how likely is a sentence. I was very interested in seeing what would happen in different levels of language proficiency in that probability, in that score. So I suspected that learners would make mistakes of some kind, either spelling mistakes or using the wrong combination of words, that would manifest as a lower probability of that sentence existing in the universe of that language, right? So that was my curiosity. And that's exactly what happened. So if you want to know more details about this, you can have a look at my paper, which was published in the proceedings of the NLP for Call conference. But yeah, you can see very clearly the distinction between the scores of a beginner and a native speaker in that language. And you can also see the score, this probability increasing as they write more, as they play polyglots more, and they are creating more sentences.
We are running slightly over schedule.
I'm just going to say another thing. So I'm going to skip the word steps. And I just want to say one thing about career, which is you can come from different paths. You can either come from computer science or linguistics, or start from scratch, either going through the full academic route or doing some self-study. I am myself a big proponent, a big advocate of self-study. So I compiled a list of resources for you so you can learn and continue learning more about this after the talk. And don't worry about writing this down. I'm gonna publish the slides on my Twitter account. So just follow me and I'll share this and you can have all of the links. And in this resources, there